Hi everyone, in today's video we're going to be talking about taking higher order derivatives. And the good news here is that you really have all the skills you need to do this. It's just going to be kind of repeating that process of taking a derivative. So the big thing here is probably going to be a little more of the emphasis on the notation than anything else. So we say that the derivative, and we know we have notation, sometimes we use the notation y prime, sometimes we'll see f prime of x. But we know that derivative is called the first derivative of y with respect to x. Sometimes we want to look at the second derivative, so in other words, we take the derivative of the derivative. Okay, and we're going to denote the second derivative. We'd say y double prime or f double prime of x, and that would indicate to me that I was taking the second derivative. So as long as we still have a function, we can continue to take more derivatives, and we call these the higher order derivatives. And we write, actually I'm not sure what we write here. We're going to write the appropriate notation to denote which derivative we are finding. So I'm going to leave that blank and then you'll see what I mean there as we get into an example. So let's look at number 1. So I have a basic polynomial function here, and we're asked to find the first 5 derivatives of the function. So essentially I'm going to take the derivative 5 times. So my first derivative is going to be f prime of x, and I'm just going to use my normal power rule. So I have 12x cubed minus 6x squared plus 2x minus 4. That's my first derivative. And now I'm just going to keep taking the derivative of that derivative. So my second derivative, f double prime of x, is equal to, let's see, 36x squared minus 12x plus 2. My third derivative, let's see, 36 times 2, what do I have, 72x minus 12. Now at this point I'm going to stop using these little tick marks and I'm going to use a number. So I'm going to say the fourth derivative, I'm going to use this notation just to make it a little easier. So now, important thing to know here is I'm not taking to the fourth power, I'm representing that fourth derivative. So in this case, let's see, 72x, that derivative is 72. I have to go one more, so the fifth. Now, my fourth derivative was a constant, which tells me my fifth derivative is just going to be 0. Okay, now the second one, it's the exact same idea, just the notation is going to be slightly different. So in this case, my function was called y. We want the first 4 derivatives. So y prime, my first derivative, let's see, I've got 3x squared minus 10x. My second derivative is going to be 6x minus 10. And you can see I'm just using those tick marks to denote the derivative. My third derivative, let's see, is just 6. And then again, I'm just going to use the number 4 now. And that derivative is going to be 0. So that's all we mean by higher order derivatives, is just taking the derivative of a derivative. Now we will look in the practice of doing some higher order derivatives with a little more complex functions, but this gives you the idea for now. Alright, that's it. See you back in class.